So, Bismillah, salatu wassalam ala Rasulullah. So, last week we discussed on the techniques of, on different types of ensemble combination, especially when it has to do with how we combine the different classifiers or machine learning algorithms to make an ensemble. So we talk about it from the point of view of either making it to be heterogeneous or homogeneous. Heterogeneous, the homogeneous is the one whereby the data set is the one you keep playing with your data set to make sure you have a different data set. Either you play with it by using different feature combinations or by doing different resampling methods. So, but then you keep the learners to be constant, to be the same. That is what made it to be homogeneous. That is, homo, as the third word means unitary, the same. So, whereas for the heterogeneous, here you can play with different machine learning algorithms. So, and from experiences and recommendations, it's always better to have different learners to come and work for you. Because when you have different algorithms, they will approach your data from different point of view, which is natural. And actually in real life situation, when you have experience from people of different background, you can see that they are likely going to come up with more robust and generalized outcome. So we discussed that for the heterogeneous, there are two ways to do it. You can actually have a learner one, make your learner to be the same while you keep changing the data. Make sure the learner is not the same. You can see from this equation, make sure all the algorithms are different because this is what made it to be heterogeneous, while keeping your data the same. However, you can also make it more complicated in the case that you are making the whole algorithm to be different. Each of them is different from the other. At the same time, you are making sure that each of the data set used on each algorithm is also different. So this like double shoveling you are going to be doing, so which make it a little bit more complicated. But any of the two you go for, that is heterogeneous. And also, we already described to us the procedure we usually use in ensemble method development. So the first is to gather the kind of individual algorithms that you want to combine together later to form your ensemble. So either you are going to go for homogeneous or you are going to go for heterogeneous. Now, after that, you get each of them trained. Then you use the individual, which we call them usually base learner or weak learner, because an individual is considered weak. No matter how powerful you are considered weak in the face of a group of people who have the same quality or even better quality as you, actually. So no matter how powerful an individual is, if you bring him or her to face another group of people that have the same qualification, definitely that individual, even though we used to consider him or her powerful, he will become weak. That is why one of the names they do give to the base learner is to call them weak learners. You should be looking at this concept, weak learners or base learners. Because no matter how powerful you are as an individual, you are weak compared to other group of people. Now, once you do then you do prediction with each of these weak learner or base models. And then finally, you are going to combine the outcome into a single output, which is what we do in Ensemble. And also we have been able to show us with different time up and up to let you know why ensemble. It takes time to build an ensemble because you have to know that. But then from my own experience, it usually pays off if you are able to do it finally. So that is why we usually use this example, that it's possible for you to have individual model that is getting 57% accuracy, 57.14. And this one, when you combine the 5 of them together, we were able to get 100% accuracy. We explained this in detail before. So what is in this kind of system? That is why it's worth really investing in Ensemble. So once you have a system, you are trying to build a model, but maybe the algorithm couldn't even understand the data to the extent you are actually expecting. You have tried several algorithms. So don't give up, you move up to ensemble. Because from experience, we have had where poor performing base learners were combined together and they achieve very, very excellent outcome, as you can see in the case of the example here. Now, so having established the importance of ensemble, then we now say, okay, today we are going to move on to describe what are the types of ensemble that we have. So that is, we want to see how do you really mix them together. So we have the general one, the one we call the simple one, the voting, which is basically used to improve prediction. We have the one we call bagging, so which is called the bootstrap aggregation. And then we have boosting. So, and then we have stacking. So inshallah, we are going to pick each of them one after the other and then see how it works. So we're starting with voting. So it's very straightforward. So we mentioned different method that you are going to do your combination later. We discussed this last week. So we can have maximum voting, averaging, we can have weighted averaging, depending on the problem you are solving. You are solving regression, you are going to do averaging. You are solving classification problem, I mean, yes or no problem or multiple classes, you have to go for voting, the one with majority vote. Now, this is the voting ensemble we are going to discuss today. As you can see from the diagram, so when you want to do ensemble through the voting method, what you need to do is your training data. The advantage of this is your training data is fixed for you. You don't need to change it. See, it's fixed for you. So what you now need to make sure you have is you're going to have a base learner here, which is otherwise known as algorithm, machine learning algorithm. So I can decide to have KNN here, k-nearest neighbor. I can decide to have support vector machine here. I can decide to have decision tree here. So use as many, you have to gather together as many as possible algorithms. So preferably different algorithms. However, some people have the opinion that even with this simple voting, you might still want to have one KNN with K set to be 7. I want to have another KNN that is set to maybe 9. So it's the same algorithm. However, it's believed that once you change the parameter, it could produce a different hypothesis. Yeah, but then you cannot compare with when you have different algorithms. So from experience and recommendation, it's always better, especially in this kind of case of simple voting idea, that you go for different algorithms. But sometimes you run out of algorithms and you still want more, it's okay. So we can bring in k-nearest neighbor that is using Manhattan distance. We use another k-nearest neighbor that is using shape distance measure. We have another one that is using different kind of distance measures that we can use. So in essence, even though they have the same name, but practically they are like different algorithms because you change the topology or you change the parameter makeup of them. But however, it's good to start with, okay, let's say we have different ones at this level. So, and I made a correction before and I'm going to make it again. So when you have data, so because we have seen people who we call KNN model. KNN is not a model, it's an algorithm. We should get that one clear. There's a difference between model and algorithm. KNN is a model, it's one of the machine learning, KNN is one of the machine learning algorithms. It is when you supply data to a model, to an algorithm. When you supply data to an algorithm like KNN, like SVM, training will take place. It is after the training, the outcome of training is actually what we call model. So when you have an ordinary algorithm, you cannot just call it model. There has to be data, then plus the process of training process, then this is what's going to produce a model. Now, so at the beginning here, you have to assemble If you want to go for heterogeneous, which I like for this kind of voting, so you go for heterogeneous ensemble here, I make sure that this algorithm is different from this one. This is different from this one, up to n. And there's so many algorithms you can use, by the way. So, and then if you want to go mixed mode, it's okay. A little bit of, okay, KNN, but I'm going to make it different from KNN by changing the parameter. It's also okay. As we are going to see, I will demonstrate this one for us, inshallah, before we go. So once you train this model, you have model 1, you have model 2, that continue up to model n. So we have trained different models now. Now you bring in your test data. As we always say that in machine learning, the training outcome is not really what is more important. What is more important is the testing accuracy. Sometimes you could have overfitting, in which case your training accuracy is very excellent, but then when you use it on scene data, it performed very badly. So we bring in test data. So this test data now, we want to check each of the algorithms that we have trained and then generate a model. Now let's tell the model coming from k nearest neighbor. So what is the outcome? This is the outcome from k nearest neighbor. What is the outcome from this? We have it here. What's the outcome from this? We have it here. That is after supplying the testing data. So we have P1, P2, up to Pn. These are the outcome from each of these models. Now you need to now vote. You can see it's very, very simple. We are not playing with data. We are not doing the sampling. We're not doing anything. No, the same data set you have. Just fix it there and then create multiple algorithms and then train them and then try to combine. So then they are now going to vote. So in which case, it could be majority voting. So if this one is saying this is yes, this is no, this is yes. Let's say we have 3. Assuming we have 3, up to P3. So that's going to be vote 2 against 1. So our output is going to be yes. And so this is a very simple example to see there. So, so we say in the case of this simple voting ensemble method, all the training data set they are usually used, it is recommended to have different classifiers. You have different classifiers to ensure the diversity of the contributions. And of course, another advantage is it has parallel execution. Parallel execution in the sense that in this class now, we can decide to divide it. All of us, everybody should pick one algorithm and use the same data to train and test and send us the results. So we can do it in parallel. You are doing your own. I'm not waiting for you to finish before I do my own. And this is the advantage of this kind of simple ensemble. So multiple people, several teams can combine together to develop different base learners, and then they can come together later to combine the result of their individual base learners so that they can have hopefully better results. So the procedure has been summarized here that you train several base learners on the training data, whereby each learner will make the prediction on the test data. So for classification, you take the majority of votes on the prediction of base learners, whereas for regression, you take the average of the prediction of base learners. So these are the unique ways that voting type of ensemble is done. And I hope that is clear to everybody. This is weka environment. So I believe now each and every one of us is a little bit very conversant with it. Now, preprocessing, you know how to load the data already. So we release the video for you to practice. So you open your data, then you go to classify. Here you're going to choose the simple one. Okay. Now, so when you go to choose, so the meta, you go to meta. So ensembles are placed a meta under the meta classifier algorithms. So you go to vote, you go down. This is the one we discussed first time, the voting method. See, this is voting method. You can see here. So you can see bagging is here. Bagging is here. We'll come back to this later, inshallah. So let's click vote. You click the vote. Now, We want to use scroll validation, depending if your data is not big, you use scroll validation, that's okay. But if you have a very big data, then you go for percentage split, in which case you want to use 80% for training and then remaining 20 for testing. So now the next thing is now you need to set up your ensemble. Remember, the first thing is you need to specify what are the algorithm I want to use. This is for voting. Now, what are the algorithms to be used? So you have, this is, how do I get here? Once you select it from here, then you go to this, you click it here. This is one voting. So this is weka classifier rule. Now you click it. Now you can see. I hope you can see it clearly. Yeah. Yeah. So here you need to add your classifiers. This is classifiers here. You can see it. This, you have to add your classifier here. So this is a parameter, but this is not very important parameters. There are so many parameters, but there are some we call hyperparameter. The hyperparameters are those that you must set them, very compulsory. And this is a major hyperparameter here, this one. You have to define the classifiers, the base classifiers that are going to form the basis of your ensemble later on. So you select it, you click. So when you click, you see something pop up here. So by default, it put this one here, 0R. This is a kind of a rule-based classifier. So we don't want it. So we can delete it. We don't want this one. We want to create our own. Now, you now have the privilege. Now you can now add, you say shoes. So I want us to play with the classifier we mentioned before. This is k-nearest neighbor. Let's add k-nearest neighbor there. So I'll say add. Before you add, you can set the parameter of k-nearest neighbor. You click here. You can see here. It's saying k-nearest neighbor is equal to 1. KNN, the number of neighbor is equal to 1. That is, if you know the status of my neighbor, only one of my neighbor, whatever happens to him or her, then you use it to classify my own situation. This is when you have KNN, the number of K set to 1. Some people think that this is too simplistic. So why don't you use 3 neighbors so that you can vote? We pick 3 of his neighbor. If 2 of them are good, 1 of them is bad, then we say this guy is a bad guy. Sorry, this guy is a good guy because 2 neighbors are good while only 1 is bad. So somebody says, okay, shoe small. So we have to check. This is what we call parameter tuning. We are going to talk about that later, inshallah. So for now, you have to set the parameter for your algorithm before you add it to your ensemble. Let's say I want you to use 5. I want you to use 5. So I set it up like that. So and then also here, it's using Euclidean distance, that's fine. I leave it that way. I say, okay. Once I'm okay with it, I say add. So it has added k-nearest neighbor into my list of base learner now. This is a base learner for me. I need to choose another one. So, like I said, you can then choose. I go to function. I want to choose support vector machine, SMO, this support vector machine. So here also I click it to set my parameter. So I want my C to be equal to maybe 100, for example. We'll see later, we'll discuss some of how to do tuning parameters. So then here also another very important thing is here. It is using polynomial kernel. If I don't want polynomial kernel, I can use RBF kernel. I change the kernel. So this support vector machine. Okay, I'm okay with the parameter I've set. How do we know which parameter to set? We are going to discuss all this as we proceed. So I click OK. Now I will say add. So I've added 2 now. I've added 2 machine learning algorithms to the ensemble I'm trying to build. So I move on, choose again. At least when you are building an ensemble, minimum of 3, because you are going to vote. So if you go for 2, it doesn't make sense, because when you have only 2, how are you going to vote? One say yes, the other one say no. So there will be a confusion. So that's why in ensemble, especially ensemble where you're going to use voting, you always need to come up with odd numbers of base learners, so that there's not going to be probability or possibility of a kind of what we call a kind of a tie, where you are not able to make a decision as appropriate. So I hope that is clear. So once you set, we set this one out. So okay, let's say we want to choose again, choose another algorithm. This time around, we have chosen a support vector machine. Okay, let me go to tree. Let me choose decision tree J48. It's a popular decision tree. Let me choose decision tree J48. So I'm choosing J48. If I want to set any parameter, I'll set the parameter, and then I will say add. Now I've successfully added 3 base learners. All of them are different. They are all different. You can see I've added k-nearest neighbor, I've added support vector machine, I've added J48. Now I need to move on now. And then I'm okay with these 3, at least for a trial. I say it's okay. So I say, once you are done, you can edit. If you don't like what you added there already, then you can remove it. You can edit it. You can move it up or down, whatever you like. The order doesn't really matter. And you can delete it and add another one. So you can always play with it. And like I said, some people have the opinion that if I'm using IBKA, if I'm using IBK, that is k-nearest neighbor, with Manhattan, with Euclidean distance measure, and k is equal to 5, some people believe that I can choose another k-nearest neighbor, but this time around, I make sure that the number of k is like 11. So I'm changing the number of k, and I'm also changing the distance measure. I'm not going to use Euclidean, I'm using Manhattan distance. Some people believe that, okay, once I do that, I can also add it. It will be taken as if it is a totally different algorithm from this one. That's why I mentioned earlier that it is also allowed. You can play with the same algorithm, and play with it in different ways to make sure that they're not generating the same hypothesis function. But for a start, we are only going to use 3. So I'm deleting this one. Now, so we have 3 base learners already created. So once you are done with it, so you just close it. You close this. Now you can see here classifiers now. You can see 3 classifiers already selected. You can see, say 3 weka classifier. So these 3 are ready to go up for you now to create a voting ensemble. Now, the next very important thing you have to select is this parameter, combination rule. We're going to talk about different combination rules later also regarding ensemble. So we go into detail later about combination rule. There could be different combination rule, but the popular one and the very easy one for people to understand is the majority voting. We have average of probabilities, we have product of probabilities, we have minimum probability, we have maximum probability, we have the median. But the popular one is majority voting, which is recommended also for a start. So we are going to choose majority voting. So now we are set. Our ensemble now is set up. We have defined the base learners to be 3, which is okay. Already we loaded our data. And now we have selected, okay, our combination rule is going to be majority voting because our data is all about classification. We are classifying maybe somebody is diabetes or not diabetes. Now, once we are done with that, then we are good to go. The other parameter, they are ignorable, number of decimal places, seeds. That is when you are breaking your data, you use the seed to determine how you should break the data. So there's no need to play with that at this point in time. So here we say, okay. So, okay. So if you want to see what you have done, you go here again and click it. It will bring it up for you. This is what you have set up. So with this now, we have successfully set up an ensemble of classifier with 3 base learners, including k-nearest neighbor, support vector machine, and decision tree. And we have decided that we are going to use majority voting for the final result. Now, the next thing, and you have selected that you want to use percentage split, 80% for training and 20% for testing. So the next is to click start, and your ensemble will start building. can see your ensemble is being built already. And I think it's done. So it will build ensemble for each of the classifiers. Each of the three classifiers, the ensemble will be built. Sorry, the model will be built for the three of them. And then a combination will be made. And then you get the final result as output. Okay, this is our final result. You see? So the ensemble generated 79.89 accuracy. So this is the confusion matrix. It's just this example for us. You know, remember in one of our classes, I told us that when you want to go for ensemble, you might need to generate ensemble as high as 105. Imagine you have to add 105 models, classifiers here. That is why I said that you can actually play with classifier, high BK with 5 neighbor, high BK with 7 neighbor, high BK with 11 neighbor. Each of them will be different classifier. It's allowed. And then once you build it, you click it off. The more you build, the better. That's why sometimes you can combine your result. Okay, you go and build 15. I build 15. Each member of this group build 15. We come back together to have 15 times 25. You can do the mathematics. You can see how many base learners we have developed. Then we now combine their results together and hopefully we get better results. So this is how the simple voting ensemble could be done. Any question at this point? I hope that is clear. So now strongly recommend that we try as much as possible to practice some of these things as we proceed, as we go along the way. So any questions? So by the grace of God, by the next class, we are going to talk about the bargain. So bargain, and then it's the advantages and the disadvantages and where to use it, where not to use it, inshallah, in our next class. So this is where we are going to be stopping for the day. Inshallah, if there's any question, so we can say this a question. We can take a few questions before we stop. Thank you very much for listening. Thank you.